is recrystallization, and it's essentially the purification of a solid by exploiting the temperature-dependent soluble differences. And although I kind of phrased it a little bit difficultly, it's just referring to the act of having to create a solid essentially using the properties of the melting point and the differences in the melting point of different like dissolved solutes, and essentially using that to create solids. However, these solids will be formed in different like temperatures because the melting point of different substances that are dissolved in the mixture will be different. So the way that we do this is we dissolve an impure solid in a minimal hot solvent, and we filter it in order to remove the insoluble impurities. Then we're going to cool slowly, so pure crystals are going to form, and then we're going to filter and collect the crystals, and we're going to dry the product. This is pretty much just how it goes. Next, we're going to look into thin layer chromatography, and again, this is kind of like an extension of the chromatography that we just talked about. We kind of use the same principles. Mobile phase, we still have the solvent. Stationary phase, we're going to have the silica plate and the paper. I guess thin layer chromatography kind of differs from paper chromatography in the sense that it also uses silica plate as a stationary phase, and it operates in the same like sort of principle. If we have greater solubility in the solvent, then it's going to mean greater affinity towards the mobile phase, so it's going to travel up the chromatography. If it has greater affinity for the solid phase, it's going to be a little bit less in terms of travel distance. Next, we're going to have two-dimensional chromatography, and this was kind of like my favorite. The reason for that is because two-dimensional chromatography is kind of like this really creative way of utilizing all the properties of chromatography. We essentially turn the paper 90 degrees clockwise and use another solvent in order to fully see which all of the substances are involved in the mixture. So if for say one substance has like same R value as another substance in the same mixture, we're obviously not going to be able to like distinguish fully all of the substances that are involved in the mixture. However, if we flip the paper by 90 degrees clockwise and then use another solvent, because the solubility of the two substances that are in the same spot are going to have different like solubilities in the second solvent, this is going to lead to them being separated as well. So I think this is again a very, very clever way of being able to just really separate all of the substances.